Well, first off, I wanted to just acknowledge the traditional owners of the lands on which we gather today, whether that's in Brisbane, throughout Queensland, or around Australia and the world, and pay our respects to their elders past, present and emerging. Now, I don't actually have a copy of the proceedings in front of me. My recollection was that we were going to lead off with Heather, but because we've... What was that, Courtney?
I think I'm up next.
You're up next. Well, I was going to say, why don't we, launch into that? And so I'd really like to welcome Courtney, who is now from Aeris, but previously Round Oak, and the CEI was originally awarded to Round Oak. So sort of wearing two hats, I guess, at the moment. And thanks so much for joining us.
Thank you. It's a bit of a interesting time transitioning over to Aeris. So I'll just share my screen. There we go. I put a little bit of information about what has been happening to us corporately.
Okay, sorry, Courtney.
Can you see that?
No, that looks good. That looks great. Thank you.
Great.
Yeah.
I'll go over our application process, our project execution, and our outcomes. Most of this will be from a Round Oak perspective. With being quite new to Aeris, and Aeris being a listed company, being a little bit conservative there. But this is now Aeris's project area, and we're looking at the North Queensland projects here. So I believe we were awarded our project in about May last year. At the time, the project was to cover 10 of our exploration leases and 2 mining leases. And then in June, we sold off 6 exploration leases and 6 mining leases to Tenant Mining or True North Copper. And then on July 1st, we became Aeris Resources, and we've got a remaining 7 exploration leases and 2 mining leases in North Queensland now, in the Mount Isa Cloncurry kind of region. So it's been a bit of a change, but now we're officially a mid-tier base metals and precious metals miner. So lots of big things to come, I think. So our project was a hyperspectral survey for vectoring of exploration targets in the Northwest Minerals Province. It covered over 1,000 square kilometres using the HiVista Corporation's HiMap and HiCam technology. Provides high resolution mineral and alteration mapping for vectoring of mineralized systems. There's a bit of technical data for the geophysicists. So it acquires spectra in 126 bands across the reflective solar wavelength. And we're looking at 2-meter resolution at the moment. We ended up taking this across our Cloncurry, Soldiers Cap and Mount Colin and Barbara sites. There was a little bit of variation between where we ended up flying the survey and our original project application. The original application didn't have our Mount Colin and Barbara mine sites in there, but they were added in at a later date so we could use them as a bit of a fingerprinting tool with the rest of our data. We've got so much data that we haven't even touched the sides looking at it, but we've just started, and we can see that we're going to have a lot of value come out of this. So a bit of history. Round Oak applied for round 4 of the CEI grant in 2020, and we were unsuccessful. I joined the company in March 2021 and reviewed the application and found that a lot of the application, the technology was great, but our approach towards how it would improve exploration and knowledge in the area really needed some bolstering. So we looked at the bones of the application, took it apart and started again. There's no denying that round oak, previously copper chem. Before that, Exco Resources have been in the area for a long time. And that shows they're pretty committed to discovery, or they were. What we've still got, we still are. I don't think you hold on to a lease from 1978 until now, unless you think you've got something worth exploring. The new approach was aligned with the strategic blueprint for Queensland's Northwest Minerals Province. And we believe it was an innovative exploration concept. So we looked at meeting the criteria of encouraging exploration in the greenfield area and supporting innovative exploration techniques. And one of the main things we chose to focus on in our second application, which was very different to our first one, is that we really worked on the collaboration side of things. Previously, the survey area was ever so slightly different, but it was still covering ground held by Rio Tinto, Glencore, Chinova, Transition Resources, and Integrated Global Resources. So what we did is we approached all of our neighbours and we said, look, we're going to be flying this survey over some of your ground. And they wrote us a letter of support, and in turn, we've handed over all of our data from that region onto our neighbours so that they can obtain value out of it as well. So definitely promoting discovery of development of new economy minerals in that area as a whole, rather than just focusing on our own tenure. One of our neighbours' ground was ever so slightly cut off. So their whole tenement wasn't included in the original design. So we went back to High Vista and they said, well, you know, planes don't fly like that anyway. We're going to be flying across there. So they included their ground extra in our survey so that we could give them a better package of data. And yeah, we've completed that data sharing since then. This is our area that we ended up flying. We've got the Soldiers Cap area to the north and our Cloncurry tenement package in that southern area. These areas were selected because they're not covered by overburden. There's not much vegetation in either of those areas, so they were perfect for a hyperspectral survey. Our primary target for mineralization is IOCG, ISSG, so copper, gold, and hopefully some enrichment of cobalt and silver with that. The abundance of chlorite and mica, we're hoping would help us vector towards mineralized zones and determine some targets in the tenement. I thought I'd try and preempt some questions here. I'm sure most people know there was a study done in 2006/7 by the CSIRO, GSQ, Geoscience Australia and James Cook University. And they used the HiMap technology to fly the survey in this area shaded in black. You can see in blue is where our tenements, well, the yellow is our tenements, and then the blue is where we flew the new survey. So previously they acquired the 22 mineral abundance maps and the hyperspectral data across there. But I just wanted to go through some of the changes to the technology, which we think have still ensured that it is innovative. The original data had a 5-meter spatial resolution. So you're looking at a 25-meter pixel area, 25-meter squared pixel area, whereas going to a 2-meter spatial resolution, we're looking at 4-meter squared pixels. The other thing in 2006 and 7 didn't include any imagery, digital imagery and elevation products. So we have a very detailed mapping. We have digital elevation data and models and imagery. So we've obtained a lot of value out of it that way as well. they've got a faster acquisition rate. They've increased their data digitization from 12 to 15 bits, and that improves their signal to noise ratio. So there's about a 20% improvement on any of the darker objects. And they've got an increased frequency of measuring the sensor, which makes their registration of images a lot more accurate. So big improvements in the old versus the new. So the technology was released, I think, in 2016, the upgrades. So yeah, about 14 years difference between the two studies. Our kind of key learnings from the project, these are our flight paths, by the way. So we have our Mount Colin is the little square to the west, and that northwest is Barbara, and then the two main flight areas there. With working for a very structured organisation, I think one of the key things we learned was to engage our contractors early, because there's always a lot more paperwork than you ever think there needs to be or can imagine. Plan for a La Nina event. So we were opportunistically trying to fly this between areas of cloud cover. So this got flown in October, November last year, which was a bit later than we were hoping for. We're hoping for about September. The wet season came in a bit earlier than planned, which I think it always does in that area. And so yeah, we spent quite a bit of time dodging clouds to acquire the data, and also planned for a pandemic. So this data is processed in Sydney, and I think we all know what happened in Sydney at the start of the year, which meant our High Vista Corporation weren't able to be in their offices processing our data. So we only just received this just before the due date for the project report. So we hadn't had a chance to really look at too much data yet. I guess probably my other advice for people who are applying in the next round is track your project changes, and I guess communication. That's not only amongst your team. We've had a lot of changeover, obviously, with the Aeris to Round Oak. We've had internal changes in staff and people owning this project. So this was originally proposed by Matt Healy, who's now CEO at Greenvale Mining. And then I've been looking at this project since he left last August. And then keeping in touch with the GSQ and keeping them up to date so they know where you're at. And collaboration. So people who are looking to apply for this, we think, look at how it can benefit the area in general, Queensland in general, and talk to your neighbours. So this is just a bit on our kind of outcomes and next steps. We've shared our data. We've reviewed some of the data, definitely not all of it. There's just too much at this stage. We are going to be merging this data with all our existing information that we've got spread throughout many different servers and sites, mainly surface geochem, all our drilling data that we've already got. And then we're going to be looking at either integrating it ourselves through GIS packages or handing it over to do some kind of machine learning AI project. So that's something we have used Mirror Geoscience for in the past. We used them at our Jaguar site in WA. But it's an option to maybe do something like that with integrating this data into our collection. I've just put a few images of some of our early kind of investigations into the data. So we've got some iron oxide alteration along the Cloncurry fault on that left image. And then you can see it bordering the Williams Supersuite on the right. This one is an abundance of epidote chlorite in two areas. So the data's identified a redox site. So hopefully for some metal precipitation. We've got on the left here, on the right, 2 different zones of areas that we've identified. So one of them is on a contact at the zone B, and that's about all. Lots to do still. We're only just at the beginning, it feels like.
Okay. Oh, fantastic. Thanks, Courtney. It's I think hyperspectral is something that's going to be used more and more, and it's interesting to see that you're talking about the increase over the last 15 years in the resolution and sampling rate and everything, which is good to see. It's I remember some of the early stuff in 2006, and it was pretty coarse and a bit hard to work around. But it also, sorry, it's not a question. I'm going on here. It's also interesting to see. I think that the processing and the mineral maps have also progressed since that time. And I guess while we're waiting for some other questions to come in, one of the questions I had for you was you spoke about chlorite and micas and also iron oxides. What other sort of relevant or not types of mineral assemblages are you getting from the contractor that are being mapped?
I would have to pull it up, the whole list. We've got, our data package is so big that we've had to get it shipped to North Queensland on a hard drive because we can hardly open it. And we had to submit it via hard drive as well because we couldn't send it via any web links. So still going through our data. I've got the list in the report, so you'll just have to read that.
Okay. Oh, fantastic. I'll look forward to that.
Yeah, read the submission report. Sorry, I've got all my screens covered.
No, that's all good. I think the report will be confidential for another 6 months. So
we're in the May submission. So ours was submitted in May, so our report should be out in November, I believe.
Yeah. Okay. Very good. Awesome. Thanks, Courtney.
Thanks.
And well done for weathering all those changes. And which company are we today? So
yeah,
it can be a little bit like that, I know.
Yes. It's hard to keep up.
Courtney, if you can just unshare your screen, that'd be great. Thanks.
Thanks.
Perfect. Thank you very much. Okay. Shall we push on with Heather next, Helen?
Why not?
Okay.
So Heather works with us in the Department of Resources and is our CEI grants manager, amongst other things. So she's going to give the viewpoint from the other side, I guess, from a bit of a history and our goals for the CEI program.
So sorry, apologies. I'm just trying to share the screen.
And she missed the screen sharing practice session at the
start. Is that working?
We're seeing your video screen, not the presentation.
Okay, stop sharing. Okay, it's when I press share screen, all I can see is the Zoom meeting.
Okay, not a share a monitor, no.
No, in the room with a laptop. There should be you should be able to select a file.
All I have is entire screen, window, or edge tab.
While we go through that,
Sorry.
We'll get Heather some IT support and we'll move on to the next speaker. Paul?
Okay, so the next speaker on my list is Simon, who's going to be talking about the work looking for critical minerals out through the Mount Cobalt corridor. Simon did catch the screen sharing practice session beforehand, and it all looked good.
Sparky, if you could just also mute yourself. Yep.
that right?
That's good. Perfect.
What?
Okay, thanks, Simon. That looks great.
Yep, we're right. You've got full screen.
Yes.
Yep. How to get rid of that bit? That's all right. I'll proceed. Basically, this is a discussion of the data we collected on our surface geochemical survey through the Mount Cobalt corridor. It's as in typical exploration program. It's got a lot of people that have contributed to it in the field, especially. So I've acknowledging all those and moving on to actual discussion of. Let me get rid of that. Yeah. Can't get rid of the top bit here. It's blanking out my screen. Anyway, what are we exploring for in the Mount Cobalt corridor? I mean, basically, we're looking for in that district. There are copper, gold, and plus or minus cobalt mines just immediately surrounding the tenements that we have as heavy metal, which are basically Osborne, Star, Elliott, Swan, and also molybdenum, rhenium resources as Merlin. We have similar geology to the only really historic producer of cobalt sulfide in Queensland, which is Mount Cobalt, which just sits outside of the tenement. And we feel that deposits with high-grade copper sulfide are the most likely to go into production quickly at relatively low cost to take advantage of battery metal demand. An additional focus was on the prospective Proterozoic granites which are in the area and their contact rocks, which have potential for rare earth elements. And we were using this study to actually give us an idea of how to explore for those elements as well. Historically, the focus in that area has been copper, lead, zinc, gold, base metal, typical Mount Isa focus. Therefore, most of the geochemistry surveys and so forth have really been focused on that, and they're relatively unexplored for critical metals. So with the CEI grant, what do we set out to achieve? So it was a surface geochem survey, determine what sampling methods produce the most reliable geochemical signal for a range of critical metals. Obviously, cobalt was in our focus because of Mount Cobalt, but we also had other interests in there. We were trying to determine which is the most effective surface sampling soil and stream sediment media. We utilised PXRF as well as a multi-element geochemistry from laboratories. So PXRF being a widely used and very cost-effective geochemical adjunct these days. And so we're presenting a real-world exploration example to screen a highly prospective area for copper, gold, cobalt, moly mineralisation, and we're also looking at the other critical metals that might be in the area, particularly the rare earth elements. Just to put you in the location, Mount Cobalt's in the southeast section of the Mount Isa block. Again, this is a distribution of cobalt resources in Queensland, and virtually none of them being mined, obviously, but or in production. But essentially, Mount Cobalt was a copper sulfide historical producer, whereas we're looking at most of these other potential resources are byproduct cobalt with other major sulfides, like the one we just heard about for Walford Creek, or lateritic cobalt associated again with byproduct cobalt from nickel at Greenvale, potentially down here at Maryborough. At Marlborough. So this is the tenement situation for south of Cloncurry. We just saw that area that the Soldier's Cap would be out here somewhere. And basically, we had an area of scattered subblock ground with fair few critical metal deposits scattered around that part of the world. Obviously, the main ones would be classified as copper, gold, cobalt. We'd put Osborne and the Stara ones and so forth in those. But we also have Mount Cobalt, which is effectively a cobalt mine, plus some other basic critical metal prospects in there as well. So this was the focus of the area down. Basically, you see Osborne is just off to the south east here. We've got Stara and Selwyn here. We've got Mount Cobalt just outside the general tenement area here, with a fairly similar geological position to what we've got inside the tenement. The general geology is Eastern Succession complex geology of Mount Isa block of schists and metasediments, ironstones in browns here, and intruded by felsic proterozoic granites of various ages, including the Williams batholith age, and then overlain to the south by Cambrian sediments. Mount Cobalt, as I said, is the historic producer in the area. The actual lode is a thin structure, narrow structure that runs basically across the screen here. It was a producer through the early part of the last century through to about the 1950s, and it's essentially a steep dipping vein system of cobalt sulfides with in a footwall here of amphibolitized dolerite, and against the sediments of, in this case, the quartzite here, but most of the hanging wall sediments you'd class as biotite schist. So the main minerals are cobalt sulfide minerals. In this case, we're looking at cobaltite, which cobalt arsenic sulfide in a biotite schist, and that oxidizes to anybody who's looked for cobalt probably in a surface environment wants to see this basically cobalt bloom, which is erythrite, which is hydrated cobalt arsenate. So our program was a surface geochem survey that the CEI supported the analysis of. We were set out as a real-world demonstration of innovative exploration technology, basically using a way of assessing previous geochem techniques that have been used in that area, plus a new or a technique that hasn't been used that much is ultrafine. So we went to do a soil survey and a stream sed survey. Basically, the soil survey concentrated on a evaluation of several media within their coarse fraction, -5 mil, +2 mil type coarse samples, -2 mil fraction, -80 mesh, and then a -2 micron ultrafine fraction. And then in the stream sediments, we also did heavy mineral concentrates, analysed these samples for 33 to 61 multi-element analysis, 4-acid digest primarily, and fire assay gold, and all that data is being reported and will be publicly available through that round 5 CEI. Just a little bit on that ultrafine technique, because this is one of the first attempts to actually do this type of work on a regional scale in the Mount Isa area. It's been common in WA, I think, but we applied it here. It analyzes the clay size fraction, so it's -2 micron. Gold and metals give stronger signals, is the idea of it. It's generally above the detection limits and increases signal to background ratios for quite a lot of elements. You do have to send all the samples to West Australia at Lab West. It's regarded as producing excellent reproducibility. You can collect smaller samples, and obviously the idea is to reduce sampling and transport. And then we did that technique along with a bunch of other media just to compare the effectiveness. Just going back historically, just to show that sample media is important when you consider a geochem survey. This is historical data before we did our survey, and it's of around Mount Cobalt and sort of east of Selwyn and Stara, has a whole series of -80 mesh samples, which is 180 micron type fraction. And this is the Cobalt plot of that area. And also in the squares here, the -80 mesh, the circles, the squares are basically a coarse fraction sample collected by CSR, who were essentially the discoverers of Osborne in the area. And they collected a thing they called, or in the media they called ferruginous gravel, which was a sample that was coarse fraction for basically. And you can see here that the numbers coming out for Cobalt, for instance, 100 ppm or so, are all coming out of that ferruginous gravel, whereas all the -80 meshes collected in the same area had less than 20, less than 25 or so. So in this particular case, a fair bit of Cobalt would have been missed if you had gone for just the fine fraction, or rather than if you'd thrown out the baby with the bathwater, if you like, and not analysed the coarse fraction. So we collected samples through that area, coarse fraction pretty well on all of the sites. We ended up with 1,000 sites, 3,500 samples, because we've collected multi samples at each site, and we did this on a 400 to 200 metre line spacing, closed it up to less than that in a few areas. So we've got quite a good coverage of the areas we were looking at. The red areas where we've collected coarse fraction, we've collected coarse fraction and ultrafine in some of these lines, and we've also collected some -80 mesh for comparison. So this gives you an idea of the distribution of our samples relative to the historical data sets. So you can see that there's most of the tenement we're looking at didn't have much historical data and had very little Cobalt, for instance. None of this was analysed for Cobalt, these grey areas, these grey samples. So here you can see on the right, you can see the data that we've collected in this survey. So we've got pretty good coverage, and then this is plotting out as a Cobalt plot for both images. What we found with the results from this, soils have been very effective at mapping out underlying geology, even in areas of intermittent outcrop. This is a coarse fraction plot of iron percent, and we can show that we've got a dolerite here, which is basically likely to be the source of any Cobalt in the area. 8% sort of is coming up with the plotting of the soils there. And if you look at the granite, it's Mount Cobalt granite here. It's less than 3% through there, so it's all nicely mapped out with that soil geochemistry. Similar with Cobalt here, this is the coarse fraction in Cobalt. We're actually getting very good correlation of the samples of greater than 100 odd ppm, 50 to 100 ppm maps out the dolerite. The less than 15 or less ppm will map out the other areas, including the granite. The higher Cobalt detected, we were just looked at previously in the ferruginous, would be coming off that dolerite, so that was being picked up by that earlier survey of the ferruginous gravel in the 1980s. The implications for exploration is that coarse fractions can be very effective delineating geochemical anomalies in areas of outcrop and subcrop. And we can show that this is one of the lines in that general area where we've got the various samples. We're plotting Cobalt here, and we can see we've logged all the samples as they've been collected. So this is where the dolerite is. It's a nice spike of the -80 mesh XRF and the coarse fraction. The fine fraction in this particular instance over outcrop didn't actually get that spike. So here's one situation where the coarse fraction is actually really important to actually analyze when you're actually doing a geochem survey. However, this is an area further south where we've got outcropping mineralisation at a blue duck, we call this, and the Broken Ridge, both of which were sort of known areas, but we did the surveys to see how they would pick up. And then we had another area up here which only had a sparse geochem anomaly from the previous, just a isolated bulk cyanide leach anomaly from the 1980s or so forth. And so this is now looking at ultrafine data, and here we've got silver on this case and the cobalt on this image on the right. And you can see we picked up the mineralisation down there in the outcropping, but we've also picked up a nice coherent anomaly in the area that is partially covered. This yellow material is basically tertiary sediments and so forth. So we get a stronger response in the if we had the CF, the coarse fraction data gets a stronger response in over the outcropping area, but gets a subdued response when we look at it. We'll look at it shortly over that area. So this is a good situation for the how the ultrafine has worked. And here we could see the ultrafine is given us a really sharp peak in a couple of spots, and we've still got a similar spike, but not nearly as enhanced as the ultrafine. So in this instance, the ultrafine's actually been really sharpens your focus, which is I guess what the general sort of idea of that survey of that material has been. So if we now look at copper, in this case we're looking at comparing copper in coarse fraction on the left with copper in the ultrafine. Again we've got the two outcropping areas of mineralisation. We can see the coarse fraction produced a nice, really coherent anomaly on both of those outcropping areas. We get good spiky anomaly, or we've got quite spiky data, but quite good data out of the ultrafine. But in this area here, we've got a fairly good coherent, we've got a nice coherent anomaly out of the ultrafine, and we've got spotty data out of the coarse fraction. So in the area where you want to probably use the ultrafine, which is where there's partial exposures and cover, it's actually appears to work pretty well here in this data set. So we've basically summarised the outcomes of this soil survey. Where aim was to delineate the surface geochem targets for copper, gold, cobalt, particularly in that area, and we've found significant anomalies at quite a few, several spots. The aim, another aim, was to see which techniques were most effective in locating critical metals in their pathfinders. Both coarse fraction soil, ultrafine soil have located significant geochem anomalies, so they've both worked. Which soil sampling techniques are ineffective and thus should not be regarded as having effectively sterilised zones? Well, in the case of the data sets, all techniques have some merit. Certainly it is not advisable to carry out fine fraction, I'd say, in the Mount Isa block without also collecting some coarse fraction, because as I said before, that throwing out the baby with the bathwater, particularly with gold, is quite important, and we see that quite a lot in eastern Queensland as well. So what was the follow up there? While we're actually out there and work the areas, our esteemed field crew collected quite a few rock chips while they were there, and you can see here we've got these anomalous soil data for, in this case we're looking at copper this side, left hand side, gold on the right hand side. We've got anomalous soils as circles, and we've got rock chips with triangles with the anomalous values coming in here with the magenta ones, and we found some significant mineralisation, including the blue duck area here particularly, but also we found some good. We found some decent anomalies that are greater than, in this case, greater than 500 up to quite a few percent copper down here, as I'll show you. And we also got some reasonable golds through the area up to an ounce type gold out of this blue duck area. So at that blue duck area, there is a copper bearing lode, quartz Gossan lode, sort of oxidized its surface there, and there's some pretty good decent copper come out of that area as well. So that's the soil survey. Just quickly, we'll look at the stream sediments. We only collected a few stream sediments, but the whole idea of this program was to just assess whether stream sediment, how effective they would be at picking up rare earth elements particularly in the granitic areas. So we collected samples we've got the Jing Creek granite and the Yellow Waterholes granite here. This is we also did it as a normal stream sed survey, and we picked up quite a bit of gold. Our main media here, we did the coarse fraction, the -80 mesh, the -2 mil. We didn't do the ultrafine in the stream seds, but we did 2 lots of pan cons. We did a first order, or heavy mineral concentrate, I should call them. We did a first order one, and then we did panned it down to a final pan. And the final pans, they're obviously have detected quite a bit of gold in a couple of significant spots. That's 13 parts per million, 1,300 or 13,000 ppb, and 380 ppb. So we've got a nice couple of gold anomalies to carry on with. But the main purpose of or the main thrust of the stream sediments was actually to see how effective it was going to be for rare earth elements. And I think we've successfully demonstrated how we can locate rare earth elements that are found in resistate minerals, which are shedding from the granitic areas of the Mount Isa block. And we've basically found that as we go from the finer fractions, -80 mesh, -2 mil coarse fraction, and then go through to heavy mineral concentrate to final pan concentrate, the total rare earth we've shown has been increased to a significant extent. So in this case, we've got a series of slides here that just show that evolution. So here we're going to -2 mil, and this is coarse fraction, and the numbers here, if you just look at these total rare earths, which we're defining as rare earth elements plus yttrium, we've got in the order of 300s or so is the highest anomalies coming out of that coarse fraction. We then go, in this case, we've gone to -2 mil. You can start seeing we're getting up to 1,000 ppm through there. We've got a few anomalies down, well, a few interesting numbers down there. Then we go to -80 mesh. You can see down here, those numbers are now increasing to 400 or so, and we're getting pretty good solid numbers through there. Then if we go to the first round of heavy mineral concentrate, which was still a lot of concentrate. We didn't really pan it down too much, but we're starting getting numbers like 3,000 and 2,000 and 700s down there. But basically, we're getting a decent amount of rare earth values in there. And then if we pan it down further to concentrate on those resistate minerals, we're starting to get 0.5% up here and 3,000 ppm. So we feel this is pan concentrates would be a very effective way of screening any areas that were suspected of having decent or rare earth potential in this part of the world. And I guess the next phase of that follow-up for there would be to screen the, this could be a more widespread technique, screening the granitic areas and contact rocks of Mount Isa with stream heads, particularly utilising the heavy mineral concentrate, facilitate targeting of those by utilising the readily available high quality radiometrics, thorium, uranium channels, particularly obviously going to give you, going to be linked to that, some of those rare earth resistate minerals. Locate the highest grade rare earth bearing primary source rocks, which will probably be in those granite or contact rocks, the skarns and so forth. And then I would think we'd want to extend that exploration search to the regolith, where these resistate minerals may accumulate by natural weathering transport processes, and then leach. If you got a situation where you could see in a laterite or whatever that they could leach that rare earth into and then precipitate on fix in regolith clays, I think you'd start looking at the rare earth type deposits that they talk about in China. So that's what we did for the CEI. It was a very effective adjunct to our program there, and it was produced some very good results for us, and we can take the certainly take exploration further on those tenements, which and hopefully lead to discovery. So that's where we're at with it. Thanks.
Oh, excellent. Thanks, Simon. That's nice to see some new lots of new data coming in there, and certainly a large survey, 1,100 or 1,300 points, I think, samples, I think you said. So yeah, great, thanks. Now the Q&A, I don't think we have any questions there. Did any of the panel have any questions for Simon? I know I have a million.
I'm just hoping he puts in another CEI so we can support some drilling on some of those targets. So
yeah, well, certainly would encourage that.
I'm not on the panel though, so I was going to say.
Yeah. If I can jump in then while we're waiting for any questions, Simon, you know, looking at 61 elements, and you spoke about you know, cobalt, copper, gold, silver, and the rare earths. Were there any other things, you know, particularly thinking about cobalt, for example, you know, nickel or the PGEs, etc., that that was sort of coming out of the data, or any other of those, I guess, less common elements?
Well, yeah, we were sort of aware of looking for them when we first started. I guess we're probably thinking of molybdenum and rhenium as because Merlin's not very far away, and so we didn't really. I guess the soil survey was primarily focused on the areas that we had the copper, cobalt, gold targets, and the similar geology to Mount Cobalt, which is the dolerite coming in contact with the sort of sediments, and basically deriving the cobalt presumably from those mafic rocks. So that we didn't pick up. You know, I'm pretty sure we didn't pick up any nickel or platinoids or whatever. I think the interesting thing, the stream sediment stuff was really interesting, because that was real greenfields. We didn't really even know that there was rare earths in that Gin Creek or Yellow Waterhole granite, and we just felt that the resistate minerals, if they were there, we're going to try and pick them up with that data, with that technique, especially just going back, back to the future with pan cons, I suppose. But it actually was very effective, and we were pretty impressed how effective it was. So there was a few elements there. I think yttrium was the rare earth was pretty interesting. I think from memory of we did actually get some good light rare earths in there. Cerium, neodymium, I think from, and so it was, that part of it was very effective. One of the things with dealing with that amount of data is you do have to have a good statistical approach to it. And we've fortunately got Tim here who can do the principal component analysis of it. And you know, when you've got 61 elements and then you throw in that's 61 from the lab, and then you throw in the ones you get from the XRF on top, you end up with a lot of elements and potentially other data that you might throw in there, you know, magnetic susceptibility or whatever. You can throw in a lot of other stuff into that principal component, and we find that a very effective technique. I actually have put that in the report, but you gave us 18 minutes here, so I didn't try and want to have to explain the principal component.
Okay, and you mentioned magnetic susceptibility there. Did you collect magnetic susceptibility and density on your stream?
Mainly on the rock chips. We did rock chip data. There was quite a bit of, we found specular hematite, yeah, quite a bit of specular hematite. There was ironstones in there, and there were some magnetic rock chips that came through. So, and the dolerite obviously is quite magnetic. So it fingerprints a lot of your samples fairly quickly. If you it's a good, I always use it because it's good numeric set of data, and it's very relevant to the lithology that you're actually working with.
Okay, all right. Excellent, thanks. I have a heap of more questions for you, but I'll leave them for another time, Simon. All right. Have you heard from Heather at all, Helen?
She's
there she is. She's online now.
She's online, yeah, and
starting screen sharing. Great.
Got it. Excellent. Good job. Down on the right, Heather. See a little. The little presentation bit in PowerPoint. Yep, that one.
Alrighty, can you hear me?
We can hear you.
Whew, alrighty, sorry about that. This would be my very first Zoom meeting, so apologies.
How have you gotten through the entire pandemic with no Zoom meetings?
They've all been Teams. So this is my very first one. So I'm just fumbling through, but thank you.
Funny. Okay, it's still not showing in presentation mode. So if you just go into PowerPoint and then just click because we can see all the little slides down the side, unless it's on a different screen. Otherwise, we could just go ahead and.
I only have the one monitor and I can only see presentation mode.
Okay. That's all.
Let's just go ahead because I'm not an expert.
Yep, we'll go ahead. All right. Introducing Heather Sparks.
Good afternoon, everyone. I'm Heather Sparks. I'm the manager for the CEI program at the Geological Survey of Queensland. And today I'm just going to give you a bit of an update on our Collaborative Exploration Initiative program. Alrighty, so just a little bit of background on the department's grants program over time. So in 2007, we started with the Collaborative Drilling Program. This program was strictly for drilling only, and we realized that it was somewhat limiting. So in 2017, we shifted to include other exploration techniques such as geophysics, geochem analysis, the reanalysis of historical core, and machine learning, and coined the term Collaborative Exploration Initiative, or CEI. So far, we've had 17 rounds collectively, with more than 900 applications submitted, and to date, 252 successful applications across the state have received funding. What makes Queensland different from many of the other states' grants program is that co-funding is not a requirement. This means companies do not have to match the funding they receive from the CEI program. Grants typically have been for a maximum of $200,000, and with all data becoming publicly available on the department's open data portal within 6 months of the program completion. So what's happening in Queensland? and who's doing the exploration. This is a really neat snapshot. It was updated recently, and it captures what's happening in Queensland. And that is that junior companies are doing the majority of exploration in Queensland. So just over 80% of all EPMs are held by junior companies.
Sorry, Heather. Sorry, go on, Helen.
I was going to say that the slides aren't advancing on what we can see. So I think we do need to, if you should be able to, in your presentation mode, yeah, you should be able to switch which screen it is. Otherwise, you're just going to have to click down through the.
Can you see anything now?
We can, no, because you've stopped sharing. Okay.
Okay, where did I leave you? Here?
I'm not sure. Whatever you were talking about, because we didn't see the slide. Yep.
Can you see this one?
Yeah.
You can see that one. Yep.
Apologies.
Doing good.
Alrighty, so one of my favorite slides. It shows that just over 80% of all the EPMs are held by junior companies across Queensland, with less than 10% of the EPMs held by either mid-tier or major companies. This distribution of tenure by market capital is just covered in purple by junior companies. And it means that the ground is being explored by companies that don't have a lot of money. And this is why I just love the CEI program, because it's a great way for the government to help these companies financially. Here's another great image of exploration activity in Queensland from 2016 to present. So the blue indicates the granted EPMs and the orange indicates EPMs in application. So you can see previously the number of granted EPMs over time has kind of remained, pretty much constant. We see the dip, a nice dip at the end there on the right, which is a direct reflection of the effects of COVID and people's sort of inability to get staff or to get boots on the ground. But the impacts of COVID have been short-termed, and spending and activities are recovering, and the outlook for Queensland is very positive. So you can see this really steep jump on the far right from the last quarter in 2021. I mean, it's just a massive spike, and exploration in Queensland is at an all-time high. So currently in Queensland, we have 1,842 issued exploration permits, with 675 companies holding these permits, and with 614 companies having submitted applications, and the largest holder being Rio Tinto. And this is where the Queensland government wants to help. So I'm thrilled to let you know that last month, the minister announced an additional $17.5 million over the next 4 years to CEI. This means that from round 7 through to round 10, we will be supporting each round with $5 million. So the global demands of population growth and the energy transition means that exploration into these higher cost frontiers is being supported to help meet the demands for these essential and critical minerals. So I'll just give you a little rundown on the last round 5. So round 5, the program ran from July 2021 to June 2022, and it has now just been completed. We had a total of 98 applications submitted, and of those, we funded 18. The activities for round 5 range from 7 drilling projects, 6 geophysical projects, 4 geochemical projects, and 1 machine learning project. Round 6 is active right now. It started in February and runs until December of this year. We had 58 applications submitted, and we are supporting 16 projects. The activities in this round range from 7 geophysical projects, 6 drilling projects, and 3 geochemical projects. So if you are currently have a CEI with our round 6, here are some important dates to remember. So please don't forget to notify us when you begin your activity out in the field or no later than September 30th. Activities must be completed by November 30th. And don't forget to, again, to notify us when you complete your activity within 5 business days. And final reports need to be submitted to the department by December 31st. And so in your final report, you have to include your final report, the interpretations of your results, any cross sections you make, all the data that you've collected. And again, you heard earlier from Courtney that sometimes the data can be quite extensive. So you might have to work with us so we can enable you to submit those large data sets. You need to submit all your contractors reports, all your QA, QC reports, and copies of all of your paid tax invoices. So the CEI works on a reimbursement scheme. All final reports and your data will be released on the Open Data Portal after we have a 6-month confidentiality period. So for round 6, we will be releasing that data after June 30th, 2023. Also, don't forget drill core and chips need to be delivered to the department no later than December 31st, 2023 as well. Alrighty, just some further obligations if you're one of our round 6 recipients. You must make sure that, ensure that all of your tenements, including all associated tenements, remain compliant. So we will be doing a check to make sure that no one has any outstanding annual reports or outstanding expenditure reports. And please ensure that your public liability insurance remains current. And if you have recently renewed it, please supply us with a copy of that so we can keep that on file. Alrighty, so how do you become eligible to apply for CEI? So we are getting ready to, we're in the process of preparing our guideline for round 7. But in order to apply, you need to meet the mandatory eligibility requirements. And first up, that means you need to have granted tenure. You need to be in compliance with all of your tenure held by the company or related entities under all relevant or applicable legislations. You also need to remain in compliance throughout the duration of the CEI. If you need to get landholder access, if that's required, that will be part of your CEI submission. So if you're thinking about doing round 7, start working on that. Don't forget, you'll need to supply your core and or rock chips to the department. Priority is given to the program's focus on the new economy minerals. And when we release the guideline, we will have them listed in there. And yeah, so we refer to the guideline. We're hoping, our plan is to release it in November. A great way to stay up to date is to join our mailing list. So when the guideline goes live, we'll do an email out to everyone so they know when it's available. So by all means, email that, our generic inbox, and we can get you on that. And yeah, we can keep you up to date with what's happening with the next round. But yeah, other than that, it looks like we've got more money moving forward, and we're pretty excited to see what's coming up ahead with all of the new exploration happening these days. Thank you.
Oh, great. Thanks, Heather. That's an excellent overview of those rounds. Seem to churn through pretty quickly. 5, 6, and all of a sudden 7's going to be coming out in November. So that's great. Thanks for that. Now I'm just having a look at the Q&A. I'm not sure if I'm having tech issues or not, but there are basically no questions coming through. So maybe they're saving them all up for the end, Heather. I guess the one question I had was about critical minerals, and you may have said it. Sorry, I had to duck out for a second. Critical minerals. So round 7, is that still with the critical minerals focus?
Yes. Yep. That will be the focus again. Yep.
Okay. All right. Oh, good. All right. If there are no further questions, thanks, Heather. We'll push on. Just to let people know, on my list, I have Neil and then David, Neil Chalmers and David A-Izzeddin yet to speak. So just to give you an idea of what's coming up next. Okay, so Neil is the exploration manager at Strategic Energy Resources, and he's going to, I believe, give us a bit of a general update on what they're up to. So over to you, Neil, if you'd like to share your screen.
One sec.
Perfect.
Can you hear me?
We can hear you and see your presentation and see your video.
Fantastic. First off, thank you for the invite for SER to talk. We wanted to talk about our drilling in northwest Queensland undercover, the extensions of the Mount Isa inlier, results and implications from a CEI grant from round 5. Forward-looking statement to read in your own time. So the outlook for this presentation, I wanted to just sort of introduce SER, the regional setting for the project, the historical exploration, the drilling, the CEI drilling, the results, implications, and what's next. So who are we? We're a small junior exploration company who have a focus on frontier exploration, so exploring undercover extensions of mineralized terrains. We're a junior, we're publicly listed. For this project that I want to talk about, we've done a lot of work trying to understand the area and doing research into the area. So we have leveraged off a lot of consultants who I thank for all their work and who have contributed to our understanding. SER was luckily enough to get 2 successful CEI grants awarded in round 5. We had a deep learning based geological interpretation study, which was the machine learning study that Heather just mentioned. And it covered both two projects that we have to the north of the Mount Isa inlet. That was a collaboration between us and Caldera Analytics, or Michael Rodder. Now, I wouldn't do that project any justice to talk about it. Michael is definitely the front runner in that work. He has recently given talks at GSQ Technical Summaries in Townsville, or workshop in summary, and that is public. So I'd ask you to refer to that if you want to know more about that one. The talk I wanted to give here is to talk about our drilling co-funding that we did, which was to co-fund 1 deep diamond hole at our Kenobi project, a target that was called G24, or the 24th gravity target, which we renamed Kalaka. And it was the application, we said it was targeting lead, zinc, silver as a Cannington analog. It was the first regional drilling program in the area since 2008, which I'll explain how we got to that. It was focusing on a discrete magnetic target within a broader magnetic low with a model EM plate and anomalous lead zinc in metasediments surrounding. So where are we? So the Kenobi project is this large tenement package that's up against the Quamby Fault, about 100 kilometres north of Ernest Henry. It is, we have almost 2,000 square kilometres. So the outcropping inlier stops here, and so we're north of Ernest Henry. You can see from the magnetics how the geology continues undercover up, is controlled by this big major structure. And then the gravity, you can see a number of significant gravity anomalies continuing up into the project area. So zooming in on the project itself, so the gravity really starts to stand out in this area. The whole area is about 100 kilometres long. The gravity highlights the complexity of the features in here. This is the RTP mag, which again highlights the major structure and then the complexity of the rocks undercover. You can also start to see some remnant features through here, which is why we've also done VRMIs and other derivatives of the magnetics to try and get a better control on those. There are 2 existing known prospects in the area. One's called Tea Tree, which was drilled by MIM and is a disseminated nickel copper in mafic system, and then Lucky Squid, which is a high-grade gold in an IOCG system. Kalaka drilling that I will talk about, if you can see my cursor, is just west of Tea Tree. So the history of exploration, the point I want to get across through here is there's only 30 diamond drill holes in the whole area which penetrates basement. They first started being drilled after the discovery of Ernest Henry. There's been a bit of a pattern of people exploring for IOCGs and finding magmatic nickel related systems, and then vice versa, looking for magmatic related systems and finding IOCGs. SER acquired it in 2016. So just to dig into that, this is the gravity map with all the existing drill holes. You can see the holes in green are the ones that have penetrated basement. The ones in blue were drilled in the 60s, looking for, which were based in the overburden. MIM first started drilling and drilled the Tea Tree holes with the suffixes TT. And they, so they identified ultramafic intrusions and subeconomic nickel PGEs before withdrawing. So that was the Tea Tree holes. Then Falcon picked it up, did some drilling of their own, and then JV to Anglo American, who did a large squid EM project, which covered the Tea Tree area. So this is the TT holes drilled by MIM here. And then Anglo drilled 7 regional holes, and it was hole 5 which discovered the IOCG work at Lucky Squid. They then passed it off to Anglo Ashanti, who drilled more at Lucky Squid, which was followed up by Falcon drilling more at Lucky Squid. So all the drilling since the Anglo regional work in 2008 was focused in at Lucky Squid, where there's high-grade gold at depth. So SER acquired it in 2016, and we originally were focusing at Lucky Squid. We drilled 2 rounds of drilling in there for 4 holes. The numbers continue to be interesting and anomalous. It's just that the geometry at depth wasn't easy to follow. So we made a conscious decision to step back and explore the broader tenement area. Having looked at the records of some of the other regional holes, there's a number of interesting rocks and low-grade intersections which had never been followed up. They've just had the one drill hole into them. Depth to basement out here is 400 meters. So every drill hole is a pinprick of information that helps us. And we need to work on getting all the information we can out of them. So SER infilled the gravity to the bottom here, looking, we like these anomalies. And then we've gone through a target generation program where we've identified up to 50 targets, either based on gravity, magnetics, and the EM. And they can be related to IOCGs, magmatic sulfides, or potentially lead zinc systems. And that led to the CEI drilling. So I'll just explain where we are. So the CEI drilling with these 2 holes here, about 3 kilometers west of Tea Tree. So what was the hole itself? So it was drilled to 907 meters. It intersected basement at 474 meters down hole. It's given a suffix A because the original attempt failed in the overburden and we had to shuffle and start again. The hole steepened as they do in out doing deep holes. It steepened so that the EM plate wasn't intersected till 900 meters down hole when it was originally designed at 750. The EM plate was not directly explained at that depth. There was no obvious rocks at that depth which were conductive. It was likely either sourced by sulfides earlier in the hole or potentially not intersected. The petrophysics confirm the magnetic and gravity responses explained by the bulk mafic and ultramafic rocks intersected. We did attempt downhole EM, especially when we saw the rocks that were coming out. We were determined to try and get downhole EM, but we failed to collect any data due to the downhole temperature being too high for the tool that was on site. So that was a lesson that we've definitely learned. And then we grouted the hole due to the aquifers in the overburden, and then collected 1 meter half core samples on all the basement. So obviously it wasn't what we expected. The drilling program targeted the magnetic anomaly, the discrete magnetic anomaly that was sitting in this regional low. But we intersected thick ultramafics, which we then look over and go, okay, well, maybe the gravity is a better way of understanding some of the geology through here. So if you look at this as potentially the gravity is mapping the mafic intrusives in this area, because all the holes within the highs have hit mafics. So as they say, drilling is the great truth teller. So a bit about the rocks and what we got out of the hole. So we did a 2-hole program, with the first one being co-funded. We hit a thick peridotite with elevated nickel and copper that graded about 0.1 with a basal semi-massive sulfide zone of grading 2 meters up to 0.7 nickel and copper as well. Petrology confirmed the cumulate ultramafic rocks and magmatic sulfides. The mineralization was dominated by pyrrhotite with low levels of nickel and copper. So we acknowledge that it's a low R factor. Some of the textures are really interesting in the hole. There's taxites or very textured mafics. There's muralitic cavities, disseminated sulfides, net textures, semi-massive sulfides. And once we saw these rocks, we engaged external help in Steve Beresford to help identify the significance of the potential of the project and build a geological framework to help put it into context. So as a geologist, we want to see the rocks. So has a couple of snapshot of them. So we have, these are all from the upper peridotite, where there's serpentinized olivine-rich whirlites with interstitial pyrrhotite. We have sulfide globules where you can start to see it start to pick up chalco and pentlandite exolving out of them. And then we have coarse Harzbergite with orthopyroxene oikocrysts. So yeah, they're really interesting rocks. You start to see some of these very textured taxites that are just overlying where you're starting to get sulfide zones. So for us, in terms of understanding what we should look for in the future when we're starting to see some of these textures, it's potential that you're in the right sort of system to keep looking for sulfides. So a bit of geochemistry on the rocks. There's they're very MgO rich. They're clearly peridotites. We've got just in this hole we have the succession through pyroxenites into gabbros and gabronorites. We've done a little bit of work looking down the hole. So the tea tree is a layered intrusion. You can see it in just this hole itself, and that's before you start to look at some of the other holes that are drilled in the area. So that the main part of hole 1A is this big thick peridotite that with semi-massive sulfides at the bottom. So we've just tried to map the rock types in these colors on the side and then use the geochemistry to show the complexity of the intrusions. You can see it's relatively consistent peridotite up here. We've taken out the pegmatites because they throw the mafic chemistry out, but then it becomes quite a complex series of intrusive ultramafic and mafic rocks. So what does all this mean? So we think that the Kenobi project contains the key criteria to form polymetallic nickel copper mineralization. And when I say that, what do I mean? I mean we're looking at analogies to some of the big boys in the nickel copper space, the Voisey's Bay and Thunder Bay and everything, to Norilsk, even though that makes me nervous to say that. So what have we seen? There's a layered mafic intrusion drilled at Tea Tree, and it contains the fertile ultramafic rocks. It's the right rocks to host massive sulfides. There's clearly sulfur saturation going on. We have a good constraint on what we think's been assimilated into the rocks to provide the sulfur and metal, and we think that that could be enough to form higher tenor sulfides in other parts of the system. The geophysical data indicates that there are favourable intrusion geometries that are potentially untested. And some of these characteristics are have similarities to some of those major nickel copper systems globally. So that would mean that we want to talk about Mount Isa as being a magmatic nickel province, and I know that's not necessarily the known thinking of the area. So looking at Tea Tree itself, we are on the edge of the inlier based on the proximity to the Gidger Shear. So we're in the right setting there. Are these potentially large igneous province rocks? Well, if they're Lunch Creek Gabbro equivalent, which they could well be, then the Geoscience Australia call it a lip when it's combined with a bimodal lip when it's joined with the Wonga Suite. And what would that do? That would mean that these rocks were potentially intruding the Corella Formation. The Corella Formation contains calcilicates and other rocks which would act as fantastic assimilants if they were to interact with magma at this age and these end member ultramafics. So that's something that we are hypothesizing about. We're working through. We're trying to understand the assimilants in not only our hole but the other holes at Tea Tree, and then look at the host rocks and try and see if there's any evidence of better assimilant rocks, acknowledging that it's very difficult to identify primary versus secondary salt minerals. So we think the rock types are right. We think the textures are right. We think sulfur saturation is right. The regional setting could work, and there are conceptually better assimilants in the system. So what are we looking at now? So what else do we need? We think Tea Tree appears to be assimilating graphite, which is shown by the EM of the squid EM, the big competent squid EM that Anglo-American did. You can see that holding together. That's probably mapping the graphite predominantly. And we think that the Tea Tree part of the system, so where the existing drilling is a static part of the intrusion. So that would essentially mean that the sulfides haven't been able to move enough and be exposed to enough of the magma to become higher grades than what has been intersected. And that's our explanation for the low tenors thus far. So what are we looking for? So we would then be wanting to look at other parts of the system to try and find a more dynamic part of the intrusion where magmatic nickel copper systems could have been trapped or funneled through chonolith type shapes, or lying down sausages be focused in, and we think that the gravity is potentially mapping, could be mapping some of these type structures, which is where we want to go next. So what is next? So we have pegged additional tenure at the southern end of the project at what we call Alcala, the southern end of the southern end gravity cluster, as possible additional mafic rocks. That part of it's never been drill tested that's hit basement. We're going to review all the available holes and build a logging and geochemical data set to try and understand the layered intrusion, which we think is vital to do. And then continue to scientifically build the model to try and understand everything from the chemical setting of the system and the assimilants that are seen in the mafic rocks and the ones that we could hope to see, and which might help guide us as to where we go next. And then we want to undertake additional geophysical processing to do everything we can to get everything out of the existing geophysical data, which including studies and other things, because really it's an available data set that we need to do everything we can. These are under thick bodies of cover, so we need to utilize everything that's available to us, and then look at doing infill geophysics, all of which will be focused on defining new drilling areas. So I guess we want to acknowledge the lots of people who have assisted with this. This is my final slide. There's this is a geophysical problem, a lot being undercover. And the CEI hole has really allowed us to pivot and look at the area completely with a fresh set of eyes. The understanding of the mineralization model has developed a lot in the last 10 to 15 years since people were exploring this area for magmatic nickel sulfide. So we're hoping to leverage off that and do everything we can to come up with compelling future targets. So that's me.
Oh, thank you, Neil. That's a fascinating part of the world up there, and as you say, a long history of exploration. And it's you just wonder who's going to be the one in that long list to jag the economic intersections. Yeah, hopefully it's you, no doubt.
No, well, hopefully.
Yeah. Okay. Oh, look, thanks for that. There is a question has come up here in the chat from Nick. Neil, do you think that pyrrhotite enrichment may be the cause for the greatest amount of remnants? Pyrrhotite is the best for this. Perhaps the more poorly remnant material may be more magnetite plus pyrrhotite. Any comments on that?
Yeah, well, the short answer is yep, quite possibly, absolutely. We're actually looking into doing some of those studies that I mentioned are involving looking at trying to do a deeper dive into the magnetics and looking at the remnants, particularly the difference between where it might be caused by magnetite and where it might be caused by sulfide. So yeah, absolutely, we're definitely looking down that path.
Yeah, okay. All right, I hope that's answered the question for Nick. Thanks for that. While we're waiting, there's a few other questions popping up, I think. I certainly had a question. Early on, you mentioned something about seeing elevated lead and zinc in the sediments, and it wasn't sure if you were talking about the cover sequences over the top or in the other drilling into the basement.
No, some of the other drilling into basement just to the north. So what we think's gone on is some of the conductors that were drilled from that squid has actually hit the edge of the intrusion or off into the host rocks, and there's lead and zinc in some of those meta sediments in skarns and other things, but also just in the meta sediments themselves. They're quite elevated, which excuse me, at the time we were linking to some of the potential holes down south. So that was the model at the time, probably. As I said, the CEI holes allowed us to pivot a little bit. But yeah, that was from basement drilling. Yeah.
Okay, all right, thanks. And my one other question was, you mentioned, obviously part of your plans is to do some more gravity infill,
Yes.
with the objective of trying to better understand the geometry of these systems and to try and find the dynamic parts.
Yep.
I'm not quite sure if you mentioned it or not, but would you comment on what is the spacing of the regional gravity there? And you said you did some infill, and then how far would you, how tightly would you infill? Because you obviously hit that point where under 500 meters of cover, you have to say, well, there's no point in infilling beyond this. Would you have any comments about that?
Yeah, okay. So the very northern end, so where we did the drilling, if you go a little bit further north of that, and it drops out to be 2 kilometer space data for the northern most tenement. That's one of the areas that we would infill. This area was actually part of the area that was flown by the Kenobi AGG survey as well, which was 1 kilometer airborne survey. And the ground gravity coverage underneath that, so the ground gravity coverage that we work with is quite good. There's sort of 250 meter space data over tea tree and lucky squid in that area, and then it's sort of, at worst, it's about 1 kilometer space in the central, and then we infill down the bottom to as detailed as 250s over the targets and sort of regionally 500 to give us our best understanding. And it does make significance especially when you start to get down to the VDs of the gravity, which like those images that I was showing is the VDs of the gravity, to try and really pick the potential arms and legs of the intrusion, if I can call it that. So.
Okay. All right. Thanks.
Paul, Simon's got a question as well. If Simon,
sorry, they're I was having trouble with that Q&A. I just wanted to know, Neil, the chonolith. What actually is the definition of a chonolith, and the tunnel geometry? I'm just wondering how that, the dimensions of that and the actual geometry of it. It sounds like it's a circular horizontal body. Is that correct?
Yeah, so
A lying down sausage.
Lying down sausage is the term that I've been told to use. It's the descriptor that I use, and the way that it's been sort of explained to me is, well, if you think that you'll have lots of magma being pushed or funneled through a lying down sausage, then that's the best way to get sulfides exposed to the magma, and it also becomes the trap at the bottom of those sausages, whether they don't have to be horizontal after things have happened to them, but they're likely to form those shapes when the intrusion breaks out along structural breaks or whatever the setting was in the host system that it was coming into.
Okay, thank you for that description of the sausage, Neil. Excellent. Yeah. Okay. So thanks for that, Neil. That's really good to hear what's happening up there, and I know you guys are doing some work in the territory as well, and I really like your approach to these. It's nice to see people getting out into some real unknowns. Well, I guess that you said there's been 30 holes there, but it's over whatever it is, 50 kilometres.
Yeah. Well, again, most of the holes are at the existing targets. Like Lucky Squid has 15 of the 30, so it's the regional holes that is where the data is most pressing, and there's the least to play with. I must admit, my ears perked up when in Heather's description of the number of the CEI proposed potential money available in the next round of CEI grants. That's fantastic. So especially for a small company like ours trying to do this kind of work, would be the best foot forward.
Okay, thanks very much, Neil. And now I can see David, who's our last speaker, I believe, today, getting himself ready. If you can organise your presentation, Dave, that'd be great. I'll just note, I know that Courtney Taylor needs to duck off a bit early, so I presume she won't be available for any discussion towards the end, but thanks very much for your presentation today, Courtney. It's good to hear about that hyperspectral work that's airborne hyperspect that's going on. So thanks. Okay, Dave, it looks like your screen's come up. We can see your PowerPoint, and now we can see your full screen. That's excellent. Thanks for that. And you're on mute. Just take that one off.
Yeah, thanks, Paul. Look, thanks very much for giving me the chance to speak today. I'm a bit like SER before us. I'm going to talk to you today about a drilling program that was part of the CEI round 5 program. This picture is a picture of the target, actually, that you can see Matthews Pinnacles, the hill in the foreground, and Mount Lation in the background. There was an interesting target we came up with, and we're very grateful to get the chance to get some funding to have a crack at this one. Just as a very quick little overview of who we are, Ballymore Resources only listed in September in 2021. We're only a small little junior explorer. Our main focus is in North Queensland. We've got 4 projects here. We've got the Mount Malloy project northwest of Cairns, the Ruddigore project up near Chiligo, the Titmar project west of Bowen, and the one I'm going to talk about today, which is the Ravenswood project. The Ravenswood project is basically located just south of Charters and east of Charters Towers. We have 5 tenements in this area covering about 300 square kilometres. I've had my eye on this area. I've been lucky enough that I was working at Ravenswood back in the early 90s, and it was a very exciting and a very successful time back then. And it was very clear that the Charters Towers area has so much potential. We considered there was a great opportunity here, and we were very lucky to get the chance to pick up this ground. We originally did a deal with Activex in 2019 and farmed into it. We earned 51%, and then late last year we acquired the rest of it. There's a whole series of really exciting projects and existing mines in this area, and we think there's a lot more to be found. Basically, our CEI project in a nutshell, I'll give you the high-level version of it. When we first acquired the ground, we did a pretty detailed review of all the existing historic data. We were very lucky that we're blessed with a lot of data in this area, but that's also the curse that there's a lot of data. Going through it, we went through and reviewed all the historic geochemical data that was available. There's some very large polymetallic anomalies in this area that are really of great interest. we also remodeled and looked at all the magnetic historic data and the IP data. And this pointed us to a number of very exciting prospects in this part of the world. One of them happened to be Matthews Pinnacle. The great thing about CEI grants is that they do give you the chance to go for, dare I say it, a bit of a Hail Mary occasionally. It's fair to say in the Charters Towers region, the focus is very much on gold. I mean, it's a prolific gold province, and that's a pretty good place to go looking for gold. But there obviously is also other opportunities in here, and I found it interesting to listen to Neil in that last talk, talking about nickel in the Mount Isa inlier. And I've actually said this before myself. I think there is great scope in the northwest Queensland to find nickel. You got major mantle tapping structures, and it's something that hasn't been recognised. But it wouldn't surprise me if someone did come up with something like that. And thinking outside the box is something that it's important. But once again, if you're a small company like Ballymore, finding the funds to go chasing your key targets is challenging enough without going after a few more interesting things that are slightly off the main game. So this was probably one of ours that was raised by one of the geologists who was working with us at the time, a guy called Angus Hornibrook. So anyway, I'm going to run you through and give you a bit of a background on it today. As I've already said, look, one of the things that we love about this tenement package is the fact that it sits in this northeast trending corridor called the Mount Lation corridor. You'd be surprised to learn that the main feature on this corridor happens to be the Mount Lation gold mine. It was a prolific gold mine, and today in the 90s, it was the largest gold mine in Australia. It produced 3.8 million ounces of gold, or 100 tonnes of gold, and it was a fantastic project. The picture I'm showing you here is of our EPM 1844. It literally adjoins the Mount Lation mine. In fact, the mining lease for Mount Lation does sneak onto our EPM there. But if you look there, you can see there's a whole series of little hills and features along there. We have a bunch of basically permacarboniferous intrusives, same age as Mount Lation, and also a series of breccia systems, and also vein mineralisation in the area. If you run through a few of those prospects that sit within there, Pinnacle Creek is a very interesting vein-hosted system in that area. Following along from the Matthews Pinnacle project, which I'm going to talk about in more detail today, sits there, and there's basically a big circular feature there which associated breccias and dikes. And beyond that, there's the Middle Mount and the 70 Mile Mount hydrothermal breccias, which once again are hydrothermal breccia systems very similar in style to what we see at Mount Lation. We're currently as we speak, we're drilling at 70 Mile Mountain, and that's another one of our priority targets. We like this area so much. Well, so we can see a lot of the ingredients of systems that you see in the other major gold and base metal systems that we see in this part of the world. You can see in this one as a direct example that Mount Lation sitting to immediately adjacent. And what we see in this area, the greater 70 Mile Matthews Pinnacle area, we see these very large, some substantial hydrothermal breccia systems in this area. We see very large polymetallic soil anomalies. We see these reverse polarized intrusives in the area. We see and alteration systems, and we do see these extensive alteration zones. And once again, a lot of these deposits seem to be related to prominent topographic highs, and we see a lot of similarities with them. It's a really impressive system and a very large area. And it's fair to say that we're not the first people to recognise this opportunity here. But look, there still seems a number of really interesting opportunities here, which is leading us to do a lot of work in this area. When we first picked up the ground, we went in there and mapped the project area to try and get a better understanding on the controls and what's happening in this area. Here's a copy of that map. The area is, unsurprisingly, hosts Silurian Devonian intrusives of the Degeling granodiorite, which is the light blue, and that's the dominant rock type in here. And it's basically been intruded by a whole series of younger intrusives. So the Degeling granodiorite is a significant hornblende biotite granodiorite. It's typically medium grained. It's slightly porphyritic. It tends to be reasonably recessive in the geophysics. It's not a particularly impressive magnetic feature or radiometric feature. It's quite bland. But if you look down to southwest in this particular area. We've also then subsequently had that intruded by the Matthews Pinnacle quartz diorite. This is once again a medium-grained diorite. It's quite substantial and extensive. It's characterised by very clear red soils in the area, but it's a very strong magnetic feature. Back in the day when it was first mapped by the geologists in the from Mount Lation, they actually assumed it was the same age as the Mount Lation intrusive complex. Probably more recent work by the Mines Department in 2018 has suggested it's more likely to be Devonian age as well. Probably of key interest to us is, I'm talking today about the Matthews Pinnacle areas. If you look into that central area there around Matthews Pinnacle, there's a very prominent ring dike that's has intruded up into this diorite and forms basically a 1 kilometre diameter ring around half a big circular feature in this area. The hill I showed you in that first picture is our first slide is basically the hill that's created by this resistive set of rhyolitic dikes. They're very coarse, impressive looking quartz feldspar porphyry rhyolites. And literally within that, you see a 1 kilometre diameter brecciated diorite. This area, this is quite an altered and shot up piece of rock in here. And it's clear that this quartz feldspar porphyry is, I guess, the upper limits of what we presume to be an underlying intrusive, which is driving up, and it's caused quite a bit of alteration and brecciation in the overlying diorite. Outside beyond that, you can see over, if you move further to the northeast, the red breccias at Middle Mountain and 70 Mile Mountain. Once again, these are significant hydrothermal breccia targets, which have a lot of similarities to what we see in Mount Lation, but they're not the subject today. In addition, there's a whole series of other numerous types of facies and intrusives. We see here lots of andesitic dikes, rhyolite, dacite dikes in the area. It's a fascinating area. The dominant structures in the area are typically northwest structures and northeast structures, like so much of this part of the world. It's very clear they've played a role in, first of all, localising the intrusives, but also the subsequent have opened up and often been host the mineralisation and the focal point for brecciation, etc. We look at the reduced pole magnetics for the same area. If you look in on a broader scheme, it's fair to say we've got a reasonably complex magnetic character throughout this area, and that's really associated to the fact that there's numerous polyphase intrusives in this area, and you see a fair bit of variability through them. The other thing of great note, which is a bit of a recurring theme for a lot of these areas of interest in northeast Queensland, is we see these areas of remnant magnetics, and you can see a very large one associated with the Matthews Pinnacle area. And also up at Gold and Black, and there's a couple of others in this area. Once again, Clark and Lackey in 2003 wrote a great paper talking about the remnant magnetic, the paleomagnetic features at Mount Lation and the Tucker's Range igneous complex. In summary, back in the Permocarboniferous, you had the Kyaman reverse superchron, which is basically a period of time where the Earth's magnetic field was reversed. And it just so happens to coincide with a period of intrusive activity in this part of the world. And so a lot of the magnetic intrusives and the associated alteration that we see with them in the Hornfels, and we see them, has actually developed a magnetic field that's the reverse of what we see today. As a result, strong magnetic highs from this time tend to form these magnetic lows. And it's fair to say that a lot of our significant northeast Queensland gold projects tend to have some substantial remnant magnetic features associated with them, including Mount Lation, Mount Wright, and there's a whole series of other ones in this area. Basically, once again, as part of our review, we also went and completed a detailed mag model of the area. And one of the things that came out of that, which we found quite intriguing, was the fact that there's some very nice coherent bodies out there, but interestingly, there's a number of pipe-like magnetic features. Obviously, once again, the challenge you face here is that you've got some bodies that are magnetic, and other things that are remnantly magnetic. So once again, there's a few challenges and a bit of trickery required by our geophysicist friends to flip things around and so we actually get a coherent model out of it. But look, once we work that out, we actually have developed a very interesting mag model through here, and we've recognised that there's a series of these finger-like pipe-like magnetic bodies that we see poking up through this area. The most interesting ones being around Matthews Pinnacle itself, which you can see in the centre of that screen, and also there's one up near Middlemount and Golden Black, which is a similar feature out there. Once we'd got that model, there was also noteworthy that a number of historic holes have been drilled in these areas that actually reported some broad zones of low grade, but very significant copper mineralisation. A couple of examples I've given here include 128 metres at 0.11% copper and 194 metres at 0.14% copper. So I guess this was one of the things that led to us proposing this hole, was that we started to think, well, is there something more to this story? Could there be a ridgeway target or a scenario here where there's some sort of potential like high level porphyry that actually has some base metal mineralisation associated with it? In addition, we managed to pull together the historic IP data for this area, which was, there was a series of lines that completed through this area, and subsequently, I must admit, we've completed more of our own to infill and fill in a few of the gaps in the historic survey. What came out of that was that, literally joining this ring dike within that breccia system at Matthews Pinnacle, there's a resistivity low. It's quite a significant low sitting in there. And if you compare that also with the chargeability, once again, there's a weak chargeability anomaly associated with that. They're also on the margins of this ring dike, particularly the north and the south, some quite strong chargeable features as well. Geochemistry is probably something that probably caught our attention in this area first, and as it probably did no doubt many others before us, it's probably one of the most substantial geochemical anomalies in the region. Very significant polymetallic geochemical anomaly. I won't waste a lot of time on it, but suffice to say, there's some very significant features out here. We're seeing, basically here's a copper anomaly. You can see it covers the main breccia system at Matthews Pinnacle, and also a fairly significant zone to the north. And it's basically of the order of 1.5 kilometres by a kilometre. Moly's a bit different. It's a bit more discrete, but interestingly, in the Moly data, you do see these two northeastern corridors on either side of the breccia system in the ring dike at Matthews Pinnacle, and they once again 1,700 metres sort of long by 300 metre anomalies. Zinc is probably the most coherent that correlates well with the actual breccia system itself. It's a very sharp 1,300 metre by 1,300 metre anomaly that sits there, and then there's some quite substantial results for it. Lead probably less coherent, but certainly highlights that northern margin of the breccia system, and there are a number of other quite interesting little anomalies through there. And finally, gold. Gold is slightly, as usual, doing its own thing. Once again, probably the most notable anomaly we see there, which is actually some data we've only recently completed. There was a bit of a gap in the historic data through this area. But there's basically at Pinnacle Creek, we see a very substantial 1,600 metre by 400 metre 100 ppb gold anomaly. There's a whole series of really crazy high results in there. I think 10 samples exceeded a gram, and it's up to 2.7 grams per tonne. In addition, another area of great interest to us is the 70-mile mount over in the northeast part of this block of survey data. There's basically quite a substantial 800 by 500 metre anomaly that coincides with the hydrothermal breccia system at 70-mile mount, which we're currently drilling. If we look at the drilling, it's fair to say and it's probably fairly self-explanatory at this point, having seen some of that geochemistry and the work that's been done in the past, there's a lot of drilling and a lot of work, and it's quite sobering the amount of work drilling that has been completed. Up to this point, there's been 119 holes completed for over 12 kilometres of drilling. But what's of interest is that the vast majority of them are very shallow holes. The vast majority are bedrock holes. There's only a handful have gone over 400 metres in depth. And what's also interesting is that there's quite a lot of significant broad intersections of low-grade base metals, particularly within that diorite breccia. Probably highlights in there include 128 metres at 0.11% copper, 194 metres at 0.14% copper, and 106 metres at 0.23% zinc and 10 ppm silver. So look, we looked at this and thought this is quite interesting, and tying it together with what we'd seen, we came to the realisation that there's this low resistivity feature that coincides with a pipe-like magnetic model structure, which is basically flanked on its sides by a chargeability anomaly. So I guess we thought we might go and push a hole into this. The plan was to do this. I say ordinarily, this would not be something we'd be chasing because this really wouldn't be in our heading zone for what we're looking for in this area. Certainly gold targets would take priority over this in this particular area. But thanks to the CI grant, we put our application in, threw our hat in the ring, and we're pleased to get this and have the chance to drill this hole. Look, running through it's a bit of a geologist's delight for logging. Well, if you don't particularly want to be challenged anyway, I guess it is. It's fair to say the hole started in quartz diorite and it finished in quartz diorite. Probably the only real fundamental change in terms of the actual geology is the grain size. In the top 100 odd metres, we're basically in a fine grained quartz diorite, and then beyond 103 metres to the end of the hole, we ended up entering a medium grained diorite. In terms of alteration through this, there is actually some fairly well defined alteration in this, which was quite instructive for us, I must say. In the upper part of the hole, we're seeing very much a variable propylitic alterations. Primarily, it's carbonate and epitite with occasional bit of sericite and chlorite with it, and a bit of hematite. But beyond 240 metres, there was a fairly fundamental change, and then we started to see more of a chlorite, sericite, hematite alteration. It is really interesting that the hematite that we see in this area, in the deeper parts of the hole, you very often will see sericite selvages around your quartz carbonate veins, and around those sericite, you then see this hematite alteration. It appears that we've got an oxidizing fluid driving a lot of this. In terms of the mineralisation we saw, well, as you can see in that first core photo, the dominant mineralisation we see here is hosted in these quartz carbonate plus and minus sulphide veins. There is definitely a notable increase in the sulphides as we go deeper. Unfortunately for us, though, while it looked very impressive, some of the veining, reality is that the dominant sulphide throughout this hole was very much pyrite, with far lesser amounts of sphalerite, chalcopyrite, molybdenum, and galena. And basically beyond 350 metres, all other sulphides apart from pyrite had departed. In terms of the magnetic anomaly we see, where we've certainly explained it, I believe, in the upper part of the hole, we see quite a lot of magnetite stringer veins throughout, and also the odd quartz magnetite vein. Below 280, the stringer veins really do die out, but we do see substantial magnetite quartz veins. In terms of the structural measurements we collected quite a lot of structural information from this hole. Veins are typically subhorizontal, and there's also a set of subvertical veins striking north-south, and another set running east-northeast, west-southwest. Looking at the assays for this, once again, it's fair to say they were reasonably disappointing. Our best intersection was 12 metres at 0.63% zinc and 1.3 grams silver, and in that, very much carrying that zone was 1 metre at 5.5% zinc and with 0.2 copper and a bit of silver. Basically, the results were overall reasonably disappointing, it's fair to say. In terms of copper, we were hoping to see a bit more copper, but our best result was 0.2% copper, 8.4 grams silver, 0.23% lead, and that 5.5% zinc. In terms of associations, we see quite a strong association between gold and lead. We also see a copper silver indium association and a zinc cadmium indium silver bismuth association. in terms of the assay results, it's also noteworthy that we actually saw increasing sulfur down the hole particularly beyond about 300 metres. But unfortunately, that's very much related with pyrite and unfortunately didn't have any base metals with it. Magnetic susceptibility is reasonably strong throughout the hole, and I think we've certainly explained the magnetic anomaly. So look, in wrapping up, it's fair to say that we didn't hit any economic mineralisation, but it's actually been a very useful hole for us regardless. We've learned a lot more about the alteration here, which is actually feeding into a lot of other good work that's going on in this area at the moment. We can see mineralisation is very much associated with these series of intense veining in places. But sadly, at this point, we haven't seen any copper or elevated copper or base metals for that matter. We are speculating about whether we've actually drilled into the barren core of the system. It is pretty obvious that there's some interesting mineralisation peripheral to it. And maybe the mistake was to be testing that magnetic high combined with the resistivity low rather than chasing the chargeable shells adjacent to it. So look, we are revisiting it. We're reviewing the work and it's fair to say, a bit like everyone else, we've had a pretty trying time getting this work done with COVID and everything happening, and even finding people and drill rigs has been a lot of fun. So we are probably still absorbing what's come out of it, but it's been a worthwhile exercise, and we're very grateful for the government for providing the grant to achieve this. And we think there's still plenty of potential in this area. Thank you.
Oh, thanks, Dave. Fascinating couple of systems there. Yeah. Excellent. Thank you. I'm just having a look in the Q&A. We don't have any questions. Everybody, feel free to put those questions in the Q&A, because I know I've known Dave for a long while, and he's always busting to tell people about exactly what he's been doing.
I can see Helen sort of jumped in the car and is heading home, so she's obviously clocked off for the day.
Oh no, I was at home. I had to duck out to an appointment, but I was listening the entire time. And now I'm in the car, and then I have to go get my daughter because Russell is in Perth, so I'm without assistance anyway. But no, great talk, Dave, and I have pestered Dave for a long time to give us a talk, so I really appreciate the effort that he's gone to here, so thanks. And
I appreciate your patience with me, Helen.
And I also appreciate the lesson learned aspect of the talk, because exploration is so I know that you wanted to talk about something that was successful, but so often exploration is all about, okay, that didn't work, what next? And
Helen, I might have said it to you last week, but look, the reality is I would have loved this hole to come up. It was it's a stunning geochemical target. There is some really amazing geophysics associated with it, but unfortunately, it didn't come up. But as I say, we are literally drilling only a kilometre or two away at the moment, and following up some other interesting work that's going on in this area, and just the insights and the things we've learned from the alteration in this area is certainly helping us in that. And so it's once again, I'm glad I'm spending your money, not mine, to build it. Hindsight, but
hang on. It's still taxpayer funds. It's still your money.
Well, it's okay. Well, so I'm contributing to it anyway. But look, and as I say, the reality is we never would have drilled this hole, and that's what the opportunity with these CI grants is the chance to go to those holes that you probably, especially when you're a little company like us, and once again, Heather's comments about how was it 83% of the tenements are held by juniors, and we're very those, extremely one of those. We need help like this, so it's fantastic to have the opportunity to do some of these, and there's some really exciting work going on out there, and I'm very encouraged by what we're doing, but getting the chance to do things like this is fantastic.
So would you go back and drill the rim of the system rather than the core?
Look, there's a few things there that I think. Can I be honest and say, if it'd been me, I wouldn't have drilled this hole. I would have drilled. The other guy wanted to do this. I just would have gone to the IP shell first anyway. But having said that, in all fairness to them, there are places where the IP has been tested and hasn't been particularly successful. successful. I think also cynically, where the IP is also possibly where we're going to find the gold rather than the critical mineral copper. So whether you would have given us the money to drill that is also something I'm not sure about, but it may have played a role in this. But
all the critical minerals are so often secondary phases associated with something more traditional like gold, and up in that area, you know, the intrusion related gold systems are essentially polymetallic. They've got a half the periodic table associated with them. So
yeah, for sure, absolutely.
Yeah.
Yeah. While you guys are drawing breath, I'll stick my nose in then.
Go on.
Yeah, and you both touched on it. It's such a large multi-metal association anomaly, particularly in the soils. And you've drilled these holes, and you were talking about it's basically called a diorite breccia.
Yeah.
If you look across that area from the drilling and the other work you've done at surface, can you see variations in the style of brecciation and or matrix? And you showed us a lot of veins and that sort of stuff there. Can you get any sort of variation through that area in the degree of brecciation and infill mineralogy that might guide you somewhere?
That's a good question, Paul. Look, in reality, Matthew's Pinnacle, I think, is typically more of a crackle breccia. It's interesting. The next two breccia pipes you see along from there are more hydrothermal. They're polymictic. There's a lot more milling and whatever is going on with those. This one, it is interesting, and I guess the other thing that with this one is that there's a lot of structure going on in here. There's but a lot of it's more looks to me like more of a tectonic breccia, or I shouldn't say maybe a tectonic, but it is more just a monomictic sort of thing that's been smashed up and a bit of space been created. There's also a lot of mineralization. It is, as you can see, clearly associated with veining and stockwork veining in this area. It does prompt the question of where you are in the system, and it's something that we are looking at in terms of the chemistry and whatever that we're seeing in the hole itself. Is there a potential for something deeper as well? It scares us looking at deeper holes when we've just drilled a 500-meter hole, being honest. But it's there is certainly potential for something like that. Look, there's the ingredients are there, and it's something that we really need to understand it better. We need to tie it in with the historic drilling. There have been some, not a lot of deep holes, but there's certainly some holes through this area that between them we've already sort of recognised some similarities in what we've drilled in our own hole with a couple of other holes that have been drilled here. Basically we need to try and work out a clever way to try and vector, and then that's what we're looking at the moment.
Yeah. Okay, excellent. Oh well, there's a few other holes, not so many deep holes you mentioned, but lots of other drilling around that might sort of help you put it together.
No, for sure.
Yeah. Okay. Excellent. Thanks. I've just seen Simon's video come on. Simon.
I'm worried now. Simon knows more about this than I do, I'm afraid.
No. But basically, David, the gold and black anomaly that seemed to be pretty special with the nice, I guess, pencil-like structure to it. Is that one of the planned?
Yeah, absolutely. I'll be honest. There was another one I put in for a CEO grant, but it got knocked back. But no, it is a really interesting target, Simon. We are going to go back there. And look, the reality is that one has got a lot more gold affinity with it as well. It's part of a pretty interesting structure that we see through that area that actually heads back towards 70 Mile Mountain as well. So yeah, it is a very interesting target. There's a nice little geochem anomaly with it that's associated with a structure. And there's that really, another pencil-like magnetic feature sitting in that area. It is fascinating how we are seeing a few of those in the area with the magnetic data we've got. And I must admit, we've probably got some more deep. We've just acquired another set of data, magnetic data that wasn't open file data, and that seems to be improving our understanding further. So we're in the process of doing the modelling of that at the moment, and that will hopefully guide us a bit more with where we're going next.
Yeah, was that gold and black? Did Normandy drill that at any point?
There are a few holes there, but there's also a bit of gold there too. So it is an interesting little target. I mean, look, on surface, a lot of it is very much looks like a more elongate sort of vein hosted thing, but there is quite a bit of alteration, and it does look like quite a, yeah, there seems like there's probably might be something a bit more going on there than just a simple little vein there. But where you do see the vein, you tend to get some decent rock chip results and things as well.
Yeah, and that Pinnacle Creek area, that was one area I did work on extensively in the going back to the essay days even.
Yeah.
And City Resources, we drilled a lot there.
I mean, there's some encouraging drill results there. I'm butting in, but yeah, quietly, yeah, you see a quartz vein there in your rock chip, and you'll get, you know, probably more often than not, you'll get over 100 grams per ton. And I don't need to tell you this, but there's some extremely spectacular grades through there. And we've just done that infill soil program. For whatever reason, there's a little patch of the grid there that was only assayed for base metals, or for whatever reason, we didn't seem to have the gold results for it. So we've gone and infilled it, collected 50 elements over it, and it's really come up with a fantastic coherent anomaly.
Yeah, no, it was interesting. It interested me, and we put a couple of holes down there, but yeah, like we never really tested it to any great depth, and those things can obviously go down to great
Exactly.
Great depths, and it had the advantage, I think, of it seems that the more gently dipping vein systems, like that was about 35, 40 degrees, yeah, exactly, dipping to the south. They tend to be the ones that have the more potential, I think.
No, I'm pleased to hear you say that. I actually am. Yeah, that's certainly one of great interest to us. There's another one called Dawn that's out further out east of Cornishman, which is very similar.
Yeah, well, I think I lost you there.
Yeah, we've still got Simon. I think Dave's frozen up. Yeah. Oh, he's back.
I'm back.
Yeah.
No, sorry, but Simon, yeah, look, I agree. The Pinnacle Creek, and also another one that we're looking at the moment is the Pinnacle Creek area. The Dawn area over near out between Hadley Castle and Cornishman, which are, once again, as you say, these flatter lying veins where we're getting base metals and also gold in these veins, and they have quite elevated lead, zinc, silver, and copper with them as well. So yeah, very interesting.
Yeah. Okay, all right. I guess we're heading towards 5 o'clock. So thanks very much for that talk, Dave. It's great to see the exciting stuff that you and Ballymore are doing. So we'll keep our eyes on the web to see what's coming next.
I appreciate it, Paul. Thank you.
Excellent. Thanks. So I'd like to thank all the speakers today for telling us all about the exciting stuff that's been happening under the CEI grant. I apologise to a couple of the earlier speakers, particularly I guess Ian, Courtney, and Heather, who we had some technical difficulties early on. So thanks you all very much for that. Helen, shall we have a little bit of a round table for people who want to pose any more questions?
Let's do that. If anyone wants to have more discussion, Paul can promote all the audience members who are remaining to be panelists and join the discussion, which, you know, sometimes is awkward, sometimes is lively. So we can give that a go. And I'll just, before we finish up the formal part of the proceedings, just give a shout out for the next GSQ UQ webinar, which will be last Thursday in August. And that is going to be, the focus of that webinar will be remote sensing. So, you know, case studies and new techniques, that kind of thing. So stay tuned for that one. But thanks to all the speakers again, and thanks for your patience while we sorted a few things out at the start, and thanks for the fantastic talks and the work that you've done under CEI, and for, you know, being such great Queensland explorers and doing awesome things that we can help support. So bring it on for the next round.
Yes, the next $17.5 million over the next 4 years by the look of it.
Yep.
Okay, all right. Oh, thanks everybody. If anybody wants to stay around, I'm clicking promote to panelist here. It doesn't seem to be happening yet, but it may.
People have to accept the invitation.
Oh,
so
okay.
Yeah. So if they're just sitting there pretending that they're listening and they're actually not listening, that's a possible reason for not. So I mean, yeah, go on, Simon.
Yeah, just while you're there, Helen, are you planning anything for that critical minerals symposium
Yes.
that we're having up here?
I am. I will be there for that one.
Oh, yeah, yeah.
I'll come up and give an update. And by that stage, we'll have actually bedded down what we're going to work on under the other funding that we've received under the Queensland Resources Industry Development Plan. So I should have some, you know, some news to share there as well. We're sort of going through shortlisting projects and figuring out what our priorities are based on feedback from industry. So yeah, I'll definitely be there.
Yep, good.
Good.
Should I stick around for the dinner, Simon?
I'd say so. It's usually the biggest event for AusIMM in the calendar. So.
Well, we should give a shout out. Yeah.
We're getting a Rio speaker this year, so it'll be interesting to see what, if they're the biggest landholder in Queensland, then interesting to see what they say. Yeah.
Well, if I was on my laptop, I could share my screen and show the flyer to everybody, but unfortunately I'm joining from my phone, so that's not going to work. Do you have the flyer, Simon?
No, I don't think I've seen it. I've sort of...
okay, anyway, it will be the 25th of August in Townsville. It's the AusIMM Far North Queensland branch Critical Minerals Forum, and there'll be a range of industry speakers. I'll be there, and I'm sure plenty of other much more exciting people than me as well. So if you consider registering, just do a little search. Otherwise, I know I'll be sharing it on LinkedIn, so look for that as well.
Okay, I'll just pop it up here. It's on the AusIMM website. It looks like
well done, Paul.
Sinead is talking there, and yeah, so that's the information. Yes, yeah.
Very good. I did promise them that I'd help promote.
Yeah.
Very good.
Oh, and hi Nick. I think I saw Nick Cook just appear there.
Oh, Nick
on the list. How you going?
Good, thanks. Yep, that was very interesting.
I'm glad you enjoyed it.
Yeah, exactly. So intrigued about everything from the cobalt at Walford Creek to the reverse remnants in the sulfides at depth, which is always intriguing. So.
Well, Cobalt came up a few times today.
It certainly did. Certainly did.
Yeah.
Yes. Yeah, Ian. I'm sorry, Ian Miller. Unfortunately, I was distracted with all the technical difficulties and didn't get to hear much of your first of your talk. And unfortunately, the recording didn't go on until after that as well. But I was going to ask you about looking at the along the Fish Creek Fault or Fish River Fault. I'm sorry. I recall seeing some Tempest airborne EM data from probably about 10 years ago, and it mapped those the pyritic units heading to the south off the Fish River Fault really well until they got to that dip where they hit the depth. But it looks like your new work might be mapping those. Is that sort of the case?
Yeah, that's exactly correct. So we're very keen on figuring out the extent of this sort of mineralized shale unit, especially close to the fault, because we do have that concentration of copper and cobalt there. And this is a large polymetallic deposit, but the buzzwords being copper and cobalt these days, that's what we're chasing. And certainly, they're all the buzzwords that everyone loves to hear at the moment. And there's some serious potential, and there's talk, this could be a really big cobalt producer in the future, and something that probably Queensland needs for itself.
Yeah,
definitely. Well, we've got some projects looking at how to get the cobalt out of the pyrite, so hopefully that will help at Walford.
Yeah, there is metallurgically, it's a tricky one, and I'll let those boffins deal with that. I'll just try and find it first. So
yeah,
a whole pile of EU. And there's a guy in Helsinki who's a guru on cobaltite and stuff as well. So there's a couple of open source EU projects which have been published on all that sort of stuff. So
yeah, right. Yep.
Is there cobaltite at Walford? I thought it was largely in the pyrite.
It's largely associated with the pyrite itself. I haven't seen anything of cobaltite mineralized at the moment. Whether or not that's something that's prevalent, sort of maybe in the higher up the sequence, but yeah, it's everything we've been sort of studying and understanding is heavily associated with pyrite. So.
Yeah. So talking about those grab bags of critical metals, Dave, I saw you mentioned indium in some of those things. From looking down the holes, basically, my guess would be that where you see the elevated indium is where you're getting the sphalerite and the correlation with zinc.
Yeah, absolutely. Yeah, very much so. It is interesting. This indium's, you're talking about cobalt. I'm seeing indium poking up in a few of our things over in Geologist. A few of our projects there seem to have some pretty significant indium in places as well, which I think is a bit of a trend up there as well with it. Diane and we or a couple of the other copper plays you have up in that part of the world. But yeah, certainly. I mean, yeah. Look, I don't think we've got an economic indium deposit there, but it's just another thing that seems to keep poking up with our where we are seeing mineralisation that seems to be there. So yeah, it's interesting.
Oh, I do remember seeing a graph recently that the forecast indium demand, for decarbonisation, blah, 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 was to increase by 250%. But,
really?
but that was starting from a pretty low.
Well,
yeah, 250% more than this, So.
Yeah, I asked Jonathan Lorraine way back, early in the piece, where you two guys said, what do you do with indium? How do you process it? And he goes, you don't. It's a pain in the ass. So I gather it's got a few challenges as well.
It basically just sort of appears, it magically appears at the end of smelting of zinc ores, basically.
Exactly. So
yeah. Okay.
Oh, good.
Good.
And what are you up to, Nick?
What am I up to?
Yeah.
Well, I've now been home for 14 days. Not so much Finland, more Victoria at the moment. So gold antimony for Southern Cross. So backwards and forwards from Victoria back to the world of stibnite and gold. But
weren't you doing some stuff over in Scandinavia?
Yep. So I'm still the chief geo for Mawson and the gold cobalt project there, and we're doing a PEA at the moment on that. So we're in the metallurgy and all that sort of stuff world at the moment. So yeah, that's keeping me very busy.
Excellent. Oh, good.
But I hope to be in Queensland a lot more.
Yeah, good.
We hope so too.
Yes, I think the last time we caught up in person, Nick, was up in Mount Isa, and you just wrapped up that drilling down south of Cannington, I think it was.
Yep, the CEI. Yep, so we had a CEI funded hole there. So we're actually going back to some of that data, and we're reprocessing some of it and thinking about whether or not we get on the ground, do some more ground surveys there.
Cool.
But again, when you've got 100 meters at 5 grams or something rather equivalent in Victoria, that seems to suck the money the other way.
Does, doesn't it? Yeah.
Yeah. Yes.
Wow.
I might just cut in and say thank you very much. I've got to duck and go. So thanks for the chance, and I'll see you soon.
Thanks so much, Neil.
Thanks.
Cheers, Neil.
Yeah. Thanks for talking, Neil. Cheers.
All right, pleasure. See you in person soon. Cheers. Bye.
Yep.
Bye.
Cheers. Bye-bye.
Yeah.
Sorry, Nick, did you say?
I'll see you in the morning at SMI probably.
Oh, okay, great. I'm actually heading over to. There's a talk tomorrow at the university, and it's from one of the survivors, I guess you'd call it, of the Brumadinho tailings dam failure. Her sister actually died in it, and she's going to be talking to the university. So that's at 10 o'clock. So I might catch you before then, but otherwise, some stage.
The Dan Alexander talk from 9 till 10.
Yeah. If you're going for that, sorry, I'll miss that because I'll be over it. But hopefully catch up some stage.
Okay, will do.
Yep. All right.
Cheers. Take care, everyone.
Cheers, Nick.
Thanks, Nick. All right. Does anyone else want to jump in? Otherwise, we might say thanks and call time.
Yep. I'm off. So thanks for everything, and thanks for the opportunity there. Helen and Paul. Excellent.
Thanks for being
Thank you.
part of it, Simon. Thanks for saying yes when we asked you to give a talk.
Yeah, that's right. Yeah. Well, I'm talking on Mount Caninda at the that one in Townsville, so that'll be a really interesting one to talk about.
Oh, good.
Yeah.
Yes. Excellent.
We're
We'll
still
look forward
getting
to
big
that.
long intercepts there.
That's what we like to hear.
Plenty of good hot copper to talk about there. Copper gold and
All right. Thanks, Simon.
Excellent.
And
Cheers now.
Courtney still seems to be logged in, so I'm going to say thank you to her, and thanks to Ian as well. I know there's been some upheaval at Aon, you know, with all the toing and froing and Pete now leaving and everything, but great to that you could step in and give that for us, so really appreciate it.
So yeah, I'm new myself, so yeah, no, it's been a pleasure sort of jumping in here today and seeing some faces that I've never met before, so yeah, it's been good.
Hopefully we'll see more of you.
Yep, no worries. Well, cheers for that, and we'll talk to you later on.
Thanks, Anne, and thanks, Heather.
Okay.
Thank you.
Now you're no longer a Zoom virgin, so well done.
I'm an expert now.
Baptism of fire, yeah.
Oh all good, all good. And thank you, Dave. Just, you know.
It was good fun, Helen. Thank you for inviting me.
Yeah, no worries. Thanks for saying yes as well.
No, look, the only last time it was because of very valid reasons, and I promise I'll.
Right.
I like to talk, as Paul does.
You do like to talk, but you're also doing everything like Nick. So we'll. I figure if I get one yes out of every 10 asks, then
exactly
I'm probably doing okay.
No, it's good to catch up, and hopefully, Paul, we can catch up in person for another coffee sometime soon.
Yeah, that'd be good. That'd be good. I'd love that. Yeah.
Excellent.
Okay. Well, you guys stay
right.
well, and we'll catch you at some stage.
No worries. Take care.
Thanks to all the rest of the audience.
Okay.
Thanks,
Bye-bye.
everyone. Bye.
Bye.